Hey, what's up? It's Jake from Nimbus DevOps. And in my previous section, we kind of went over execution time of various expressions using comprehension and generators. And if you recall, we had to initialize a variable to start time and subtract it from the current time after execution in order to calculate the elapsed time. We also printed it in the console after each measurement, and that was kind of tedious. Every time you find ourselves repeating things, you should have an alarm going off in your head that's like, is this really the best way to do this? Can we put this in a function to avoid repetition? And most of the time, the answer is yes. So let's take a look at an example of doing this. So let's say from time import sleep and time. And then we're going to define some function f, and we're going to say sleep 0.3 seconds. And then I'm going to define a function g and say sleep for 0.5 seconds, and then I'll say t equals time and call f and then print f took and then comma time minus t. All right, so however long that is. And then I'll say t equals time and then g, we'll just call g and then say print g took and then time minus t. So in this code, we define two functions, f and g, which do nothing but sleep for zero point 0.3 seconds and 0.5 seconds. We use a sleep function to suspend the execution for whatever amount of time you want to suspend it for. And notice how time measure is pretty accurate. Okay, so like in the times I've done this before, is very accurate. So if I call this decorators file, you can see it's hyper accurate. Look how many decimal places this is. Um, but how do we avoid repeating this code and these calculations? So one potential first approach could be to define, do our import. We define our f, we define our g, and then we could define a function called measure, and then just pass func, and then just say t equals time, and then call func, right? And then we'll just print uh, whatever function dot and then the name of it, uh, comma, and then took, comma, time minus t. So I could do something like that. And then I could just say measure, right? I'll call my function measure f, and then I should probably spell it correctly. It works better that way. Measure f and measure g. And for the time being, I'm just going to take this and comment it out and look like something like this. Okay, that's a lot better, right? And I got the same result. I just kind of cleaned it up a bit. The whole timing mechanism's been encapsulated in a function, so you don't have to repeat it. I can just call measure. We print the function name dynamically, and it's easy enough to code. But what if we need to pass any arguments to the function we measure? So the code would get a little bit more complicated. And we can look at another example of this. And if I were to just, let's just get rid of all of this for now. And let's say we want to go define f, but I want to sleep underscore time equals 0.1, and then go sleep, whatever the sleep time is. Sleep time. I could do that. And then I could define measure and say func, and then args, and then kw args, like this, and say t equals time, and func args, and kw args, and then just print func dot name took time minus t, something like that. I could do something like this, right? And then just, I have two functions and I just need to actually call something. So measure, and then I'll say f sleep underscore time equals equals 0.3, and then measure f 0.2, something like that. And what happens if I run this? I still get something similar. So f is expecting to be fed a sleep time with a default value of 0.1. So we don't need g anymore. We got rid of g completely. We also had to change the measure function so it now accepts a function, any variable positional arguments, and any variable keyword arguments. In this way, whatever you call measure with will redirect those arguments to call the function. We do all that inside. So that's really good, but you can actually push this a little bit further and say you want to have that timing behavior built into the f function. So we could just call it and have the measure taken. And here's one way to do it. So we could do define f sleep time 0.1 sleep time. That's fine. So we can get rid of this and say define measure func, and then we'll define a wrapper for args and keyword args, and then just say t is time and the function args and keyword args, like that. And then we could print func dot name took time minus t, like that. And I have defined this wrapper, and then I would just have to return it. So return wrapper, like that. And then f, in this case, you'd have like a f equals measure f, and that would be a decoration point, and then f of 0.2, f sleep underscore time equals 0.3, and I could do a print f dot name, so we can look at this too. This is going to be gross. Okay, here we go. Wrapper. It just returns wrapper. So this code's probably not straightforward. So let's see what happens here. The magic in it is the decoration point. So we basically reassign f with whatever is returned by measure when we call it with f as an argument. Within measure, we define another function, wrapper, right? We find that here. So that's like nested in there. And then we return that. So the net effect is that after the decoration point, when we call f, we're actually calling wrapper. And you can witness this in the last line of code. Since the wrapper inside the function, which is f, we're actually closing the loop. The wrapper function, not surprisingly, is a wrapper, and it takes a variable position and keyword argument, calls f with them, and then does some time measurement, calculate it. And that's pretty much it. So this technique is called decoration, and measure is effectively a decorator. The paradigm is pretty popular and widely used. Started out in Python 2, and there is a PEP on that, 318, I think is what it is. In Python 3, the decorator syntax was kind of amended a little bit to relax some of the grammar restrictions. And we can explore three cases of this: one decorator, two decorators, and one decorator that takes an argument. So let's take a look at that. So if I were to do that, I could say define a function and take arg1, take arg2, etc., like that, and then say pass. Define func. There we go. And then whatever, pass. And then I could just say function equals decorator func. Decorator func. Like that. Okay. That is essentially the equivalent of saying at decorator, okay, which is like a new thing that we're doing. Oh, come on, autocomplete decorator. I just want to hit enter. And then running the same thing here, like that. At decorator, define function argument, however many arguments pass. So basically, instead of manually reassigning the function to what was returned by decorator, we prepend the definition of the function with a special syntax at whatever the decorator name is. And you can apply multiple decorators of the same function. Um, so instead of saying like at decorator function, like maybe I had deco1 and I had deco2 and then some function like this. You could just say deco1, deco1, and then like at deco2, something like that. And you could do it that way. And that's, I think, a little bit easier to see. But when you apply multiple decorators, it's important to pay attention to the order. So in this example, function is decorated with deco2 first, and the result is decorated with deco1. So a good rule of thumb is the closer the decorator is to the function, the sooner it's applied. And some decorators can take arguments. So just think of it like nesting, right? So this technique is generally used to produce another decorator, in which case the object would be called a decorator factory, which I'll get into later. But let's look at the syntax of a simple example. So if I said define func arg1, arg2, etc., pass, func is, and then I'll do a decorator argument, right? So deco arg, and then I'll just say arg a, and then there's an arg b, and then some function afterward, is basically the same thing as saying at deco arg. So I have a at deco arg, and then say define func arg1, arg2, etc., and then just pass. So in this case, it's a bit different. The first deco arg is called with the given arguments, and then its return value, the actual decorator, is called with function. So before we give you another example here, let's fix one thing that might be bothering you, and that's taking a look at the previous example with define measure. So we don't want to lose the original function name and the doc string when we decorate it, because inside our decorator we can return a wrapper. The decorated function f is reassigned to it, and then its original attributes are lost and replaced with the attributes of your wrapper. So there's an easy fix from this, and there's a func tools module you can use and rewrite the syntax with the at operator. So in this case, I could say from time import sleep time, and then also say from functools import wraps. Okay, and then I can say define measure of a function, right? And then at wraps func, and then define myself a nice little wrapper here with my args and my keyword args, and say t equals time, func, we'll do args and keyword args again, keyword args, and then we'll just print the function dot name took time minus t, something like that, and then return the wrapper. And then down here I can say at measure, and then define f sleep underscore time equals 0.1, and then something silly like I love to sleep, something like that. Sleep is whatever sleep time is, and then we will actually call this with f sleep underscore time equals 0.3, and that'll give us a value, and then we can also print f dot whatever the name is, and then I'll do a little colon, f dot underscore whatever the doc string is, and that should give you the doc string as well. What in the heck is he talking about? There you go. This is much better. So you can see all you need to do is tell Python that wrapper actually wraps func by means of the wraps function, and you can see the original name and the doc string are actually maintained inside of this. Um, I could do a couple more examples. I think you might get the picture or might be like, what the heck is he talking about? If so, just watch it again. Um, so it is possible to enhance the measure decorator so that the wrapper now returns the result of the call to function, and some sort of like decorator that does that, that checks the result is not greater than some other value, or whatever logic you want to put in there. Um, so it's entirely possible to do that. And you can separate the calls with blank lines to make it a little bit easier, et cetera, et cetera. You know what? I'll go ahead and do it really quick just so you can see it. So if I did from time, import sleep time, import wraps, define measure function at wraps, we'll define our wrapper, args, keyword args, time, result, leave. All this the same. So all we're going to do is in here, I'm going to make a result and say, hey, I have a result and it's the function, and then I'm going to pass the args and the keyword args. Okay, and then I'm going to print, instead of just saying this, I'm just going to set a result to that, and then print the function name, took however much time, and then before I return the wrapper, oops, I'm actually going to, inside of here, return a result. Okay, then I can, after this, say, I want to define a max result with function as an argument, and say at wraps func, define a wrapper with args and keyword args, and result will be the function of args and keyword args. And if that result is greater than 100, then print something. Print f result is too big, and then let's give a result inside. Result, singular. There we go. Result, period. And then on the next line, we'll just say max allowed is 100, something like that. And then underneath here, I can, inside of this if, right outside of it, I mean, return the result. And you'll never guess what I'm going to do after it. Yep, I'm going to return the wrapper. Return wrapper, like that. And then down here, I can say at measure as my decorator, and I can also add at max result. And then let's get rid of this and say define cube n, and we're just going to make a simple function and just return whatever n cubed is. That's what we're going to do. Return n cubed. And then to call, now that we've defined all of this, we actually need to call something. So we just want to print whatever cube 2 is. So this is a very, very complicated version of what we did earlier, which is like, hey, make a function that cubes a number, right? So let's print and then call the cube function again, if I can spell correctly. Lord almighty. 5. So what do you think is going to happen? Well, let's take a look. Cube took 0, 8. Result is too big, 125. Max allows 100. Cube took 0, and then 125 is the cube. So it's not that long. So the problem is you say cube took however long, and here, where's my, there it is, time minus t. So I don't like that it's rounding. So t is time, result is func args print function name took time minus t, and that was it. Yeah. Anyways, I'm not gonna worry about the time. That's not the point. But you have to enhance the measure decorator so that the wrapper now returns the result of the call to the function. The max result decorator here does that as well, but before returning it, checks the result is not greater than 100, which is the maximum allowed, which you saw it did here. So we decorated a cube with both of them, and the max result is applied, then measure. So you'll see here max result is applied, and then the measure is applied. So it goes inside out. Okay. Uh, I separated these with 2 calls just for convenience. In the first call, the result is 8, which passes the threshold check. The running time is measured and printed, and then we print the result 8. On the second call, the result is 125. The error message is printed, the result is returned, and then it's the turn of the measure decorator, which prints the running time again, and finally we print the result 125. Okay. If we had decorated the cube function with the same 2 decorators but in a different order, the order of the printed messages would also have been different. So if, like, for example, if I just cut this, pasted this up here, saved it, and ran the exact same thing, it'd be like, hey, this is how long it took. By the way, it's too big. So the order matters. Okay, that's the big thing from that in the decorators. So there you go. That's the beginning of our conversation about decorators, and next we will get into decorator factories.